Hello everyone. Welcome to this training session on t-tests using SPSS. Now, what is the purpose of getting into this t-test? The main reason of getting into a t-test is to compare the means. Compare the means of different in different mechanisms. So there are three major kind of comparison of the means which we typically do. Though there are various varieties, the most common of the comparison of the means which generally we get into are three. Wherein the first one is like I compare the mean with a constant value. Compare the mean with a constant value. So I want to really check out whether the mean of a particular population is equal to a constant. Can I take that it is more or less same as a constant, or is it very much deviating from the constant? So we need to do some kind of a hypothesis testing on the top of that. Then we call it, we compare the mean of population 1 with the mean of population 2. Like an example of the average height of an Indian male is more or less same as the average height of a US male. Something like that. Or probably it is more than the average height of a US male. Something like that. Whenever I want to compare the means of the two populations and I want to make a conclusion regarding the means of the two populations. If I want to make a conclusion regarding the mean of one population as equal to something or not equal to something, I can go with the first kind of mechanism. If I am not looking at comparing with a constant value, but I am more looking at comparing with another population's mean, I am looking at it as the second. And the third typically goes as a pairwise comparison. Like, okay, the on an average, the height of an Indian male is 5 centimeters more than his spouse. So here we are typically looking at it on a pairwise basis. On an average, each pair's difference is what we are comparing and then validating it with a constant. So those kind of things typically are the three kind of t-tests which we are going to discuss as a part of this particular session. So statistically, I really have to make a conclusion regarding the means of the data, and come looking at the sample. If I have to make some kind of conclusion regarding the populations as far as the means are concerned, I will resort to this t-test mechanisms. So coming to SPSS, there are three types of t-tests that are available. There is a one sample t-test, which is for comparing the mean of a population with a constant value. Then we have independent sample t-test, which is primarily for comparing the means of two different populations. And we have a paid sample test where we are primarily focusing on comparing on a pairwise basis, right? So we'll look at each one of them with our examples. So especially when I am using this one sample t-test mechanism, it is primarily helping me out to test the difference between the sample mean and a hypothesized value. So probably going back to our data set, based on the data set, I would like to create here one thing saying, I want to compare, or I want to test the difference between the sample mean of runs per hour with with 7.5. So I'm making a hypothesis saying that the average mean runs per hour, the mean runs per hour is equal to 7.5. I want to test it out whether that statement can be rejected at least 95% confidence level. So I can set my own confidence level at which that statement can be rejected, which means when I am rejecting a statement with 95% confidence, probably it's as good as a very strong evidence to reject that particular statement. So we would like to use the one sample t-test for that purpose. So I'll use this example saying sample mean of runs per hour. I want to check it whether it is very close to 7.5 or it is very much deviating from 7.5 and cannot be accepted. Okay, just to bring out what would be the hypothesis which I would be testing in this case. As we have already discussed earlier, the null hypothesis always talks about the equality. So here my null hypothesis will become the mean is equal to 7.5. Whereas my alternate hypothesis will not contain equality. So I'll say the mean is not equal to 7.5. This is what I'll be testing as the null hypothesis versus the alternate hypothesis. And I know that if I have to compare the mean of one single population with a constant value, I will resort to one sample t-test. So these are some of the things we need to be comfortable with. For checking what aspect of features, what kind of SPSS mechanism needs to be used. So in this case, I will be using this specific mechanism of one sample t-test. So to get into that, right, I'll start with, if at all I want to look at again the same logic all across or even within various groups. Okay, for example, let me start with looking at it all across itself, right? So what can I do? I'll get into the data, I'll get into analyze, compare means. So in this compare means, these are the three things which we will discuss in this particular session. One sample t-test right now which we are going to deal with. Okay, I'll say the one sample t-test. I want to compare the runs per hour with a test value of 7.5. I'll compare the runs per hour with a test value of 7.5 and that's it. So if I click on OK, so I'm getting a result. Now if you can see what is the result, let's walk through this result. Okay, the N number of records that were considered was 652 and there is a mean which is 7.53. This is from the sample. We have hypothesized it with respect to 7.5. My sample has given a calculation of 7.53. Along with that, some standard deviation of 1.62 and a standard error. Standard error is nothing but sigma by root n. 1.62 divided by square root of 652 is what is typically given by the the standard error. Now, how do I make a conclusion based on this? Getting into the technicalities, there is a t value that would be created based on the data. It would typically compare, the way the t value is computed is your sample mean 7.53 minus whatever is the hypothesized mean which you had 7.5 divided by the standard error of the mean. So we don't need to get into the calculations and formulas part of it. My interpretation side is very straightforward. You look at the significance value. In this case also you look at the significance value. In our example, the significance value is 0.581. So the significance value came out to 0.581. This is the only value that we really require. If this value is less than 0.05, then go with the alternate hypothesis. We say we are rejecting the null hypothesis. So I will say that the mean, I'm 95% confident that the mean is not equal to 7.5. But if the significance value is greater than 0.585, 0.05, I don't have sufficient evidence to reject this null hypothesis. So just one single value, though SPSS is generating so much of output for us, what is very much important for us here is only this number of significance level. If at all I am getting that significance level less than 0.05, my business conclusion is the alternate hypothesis saying that the mean is not equal to 7.5. Mean is very much away from 7.5. But if I am looking at the significance value greater than 0.05, I cannot reject the null hypothesis. So I am forced to go ahead with this null hypothesis of there is not much of a difference between the sample mean and 7.5. There is no significant difference in the means between the sample and 7.5. That's the typical way we make a business decision from this. So typically when we are using the tool, we really don't need to get into the various technical aspects or the calculation aspects, but just to be aware a little bit, the mean difference is 0.03, which is 7.53 minus 7.5 is giving me this number, and a 95% confidence interval is built based on this standard error. This number minus 1.96 times the standard error to this number plus 1.96 times the standard error gives me the 95% confidence interval. But yeah, we don't need to look at all these. As far as the t-test is concerned, my major intention is to assess whether a particular statement be accepted or it needs to be rejected. So in this case, I cannot reject the null hypothesis of 7.5. So I can very well go ahead saying the sample mean of runs per over is somewhere around 7.5 itself. So that statement cannot be rejected. Now the same way, if someone is making a statement instead of 7.5, for the same example, just to showcase that, if someone has made an example of 8, right, instead of 7.5 I am setting it to 8, you see that the significance level is almost close to 0. So significance level is less than 0.05, then you can very well make a statement that the mean runs per over is not 8, it is much away from 8, and because the difference is negative, you can very well say it is much lesser than 8, right? With 95, or even the way you tell is you take the 100 minus this with almost 100% confidence, 99 point some, because this is a kind of a rounded up number. So with 99.99% confidence, I can very well say that your statement of the mean runs per over is 8 can be rejected. And I'm very much sure that the value is, the average is much lesser than 8, typically somewhere around 7.54, 7.55 kind of thing. So that is how you typically build up the decisions regarding the comparison of a mean with a particular value. All right, so that is where you use the one sample t-test. Now let's look at the next scenario where we talk about two independent samples. If I want to talk about two independent samples, probably I'll create one simple question wherein uh, the mean of Australia, the mean runs per over of Australia is greater than the mean runs per over of India. India is having a country code of 10 in our data. Australia is having a country code of 1. I want to test out whether there is a uniformity in the runs per over, whether there is a statistically significant difference between the mean runs per over of Australia versus India. This is what is, so which means I am trying to compare the averages of two different groups of data, and I want to see whether that difference is statistically significant or can very well be ignored. So that is what is the main job of independent sample. I am having two different samples means, and I am trying to test if the difference between the two sample means is statistically significant or not. So here we would also consider not only the means, this procedure will see internally that it will just not consider only the means, it will also look at the equality of the variances of the two samples. It will also look at the equality of variances of the two samples, and we can even get a 95% confidence interval of the difference, right? What is the typical difference which can say that it is at 95% level of confidence? So what do we do for that? We have already created a kind of equation scenario. So let me go back to the data and see how we execute the same, right? So we can very well select compare means, the same analyze, compare means, and here I'll go with independent sample t-test. So here I can specify the runs per over, and the grouping variable I would like to do on the country code. So here it asks me for the groups, the two groups based on which I would like comparison. So this is applicable only for two groups of data. In case I have more number of groups, I'll tell you what we need to do. We have another procedure if at all I have to compare the means of more than two groups. But for the time being, to compare two groups of data, I can resort to this mechanism of independent sample t-test. So here I am defining the groups. The group 1 is having a value of 1 and group 2 is India, which is having a value of 10. In some cases, if my group variable is a nominal variable, is not a nominal variable, it's a scale variable, then I would be typically looking at putting a cutoff point. I would very well be going ahead with a cutoff point saying any number below this is one group, any values, the records with the value above this into a different group. Even those kind of things can very well be looked at. Here let's say I am putting a simple group number saying group 1, group 2, group 1 having value of 1, group 2 having a value of 10. Alright, and I can typically go with OK, wherein now it gives me some important conclusions. The runs per over, this is a kind of a very basic group statistics document, right? the group statistics document is giving me that in Australia there are 63 matches that are played with a mean of 8.24 and a standard deviation of 1.52, whereas India was involved with 44 matches with a mean of 8.00 and a standard deviation of 1.24. So apart from that, it, as I said, it first looks out for the equality of the variances. For equality of the variances, there is one test called Levin's test, which is performed on the data. So the first thing I have to look out here is the significance level associated with the F test. So the null hypothesis as far as the F test is concerned is the variance of Australia's runs per over is equal to variance of India's runs per over. That is the null hypothesis. The alternate is not equal. Now the same logic again holds true. I will check out for the significance level. If the significance level in this case is the significance level in this case is 0.225. So we are checking it if this is less than 0.05. If it is less than 0.05, then I would have gone with alternate hypothesis saying the variances are not equal. But if it is more than 0.05, I don't have the evidences to say that the variances are not equal. I have to go with the assumption of variances being equal. So in this case, I know that the variances are equal. So here the system has given the two outputs as far as the comparison of means is concerned. One is under the assumption that the variances are equal. The second one is under the assumption that the variances are not equal. But now we know that the variances are equal. We have already looked at that number. So you can easily assume that the two groups have equal variances. So the second line can very well be ignored. So what can we do to make that report more and more better? You double click on this. You double click on this, and in that pivot table you can change the default. So I'll go for a pivoting trace, and what you can very well do is you can the assumptions you bring it here. If I bring the assumptions here, okay, let's see what is going to happen. Yeah, it is coming out that here the equal variances assumed versus equal variances not assumed is showing in the tray here. So now I'll go with equal variances assumed. Only this part is sufficient for me. So I'll close this under this scenario that the equal variances are assumed. So based on that, I will look out for the t-test. Once I have done the equal variances assumed kind of a panel, I'll typically check out the equality of the means. Now, what do I go with equality of the means? Again, I'm looking at the significance level for the t-test. I got 0.386. And as I have already mentioned, again this is compared with the 0.05. If this is less than 0.05, I'll go with the alternate hypothesis saying there is a significant difference between the means of Australia and Indian RPO. But if it is greater than 0.05, just like the way we got right now, this is greater than 0.05, I cannot reject the equality at 95% level of confidence, which means I'm going ahead saying that there is no significant difference between the means of Australia as well as India as far as the runs per over is concerned. There is no significant difference between Australia and India as far as the means is concerned. So this is how we typically use the independent sample t-test to come out with a conclusion. Had this number been less than 0.05, I could have very well concluded that there is a real significant difference between the means of Australian runs per over and Indian runs per over. So the confidence interval of the difference is lying between minus 0.3 to plus 0.7. So there is a 95% confidence that the differences in the averages between the two countries means can lie anywhere between minus 0.3 to plus 0.7, and because 0 is also present, we cannot reject the statement regarding the equality of the means. So that's the reason we are not rejecting the equality. We are going with 95% confidence, saying there is no evidence to reject the equality between the means of the run per over for two different countries. So this is how we execute the independent sample t-test. Now, we are looking at the third mechanism, which is the paid sample t-test. Especially when we have designs like pre and post. The before some experiment or before a treatment, I'm checking for one value. Post the treatment, I'm checking for the same value. I want to see what is the difference between the two. Is there any kind of a significant difference before and after? So anywhere I want to look at pair-wise comparison rather than group-wise comparison, I would like to go with a paired sample t-test. So generally for pre-post, like before visiting the doctor or before visiting a weight loss institute, I will check up for my weight, and after receiving the treatment from the weight loss institute, I will check up for the weight. I want to see whether there is any significant drop in the weight after the treatment or after the kind of a medication. So these are some of the places where you can very well go with a paid sample t-test. And what it simply says is, if the treatment had no effect, the average difference will be more or less around 0, and the null hypothesis, here we set the null hypothesis as the difference is equal to 0 or difference equal to some hypothesized value. If I'm saying the difference between a male and his corresponding spouse is 5 centimeters, then probably I must set d equal to 5. So the alternate hypothesis will be d not equal to 0 or 5. When we are talking of pairwise significant differences existing, then we can go with the difference is equal to 0 versus differences not equal to 0. So for this, we don't choose two groups of data, we choose two different variables for the same record. If I am doing a pairwise or paired sample t-test, I am more doing a selecting two different variables as a pair for the same record. That is what is going as a part of this paired sample t-test. So in our example, again, I would like to create a question saying, I want to test out for the differences between the, let me look at the data and create a question. Yeah, first we get partnership is there, this column. the first wicket partnership and probably the total runs. I want to see whether there is any kind of uniformity in the differences between the first wicket partnership and the total runs scored. Right, I want to see whether if the first wicket partnership is higher, the run scored is higher, and vice versa. I want to check out for the equality of the difference between the total runs and the first wicket partnership. So basically all we are talking of is two different values, like before the first wicket fell, the score and the total score. I want to check out for the comparison between those two groups of data. So that is where I can resort to a paid sample. So simple logic here is I want to look out for the same record. I want to test out these differences, if these differences are more consistent or not. That is what is the major intention in the exercise. All right. So I'll go for compare means. I'll go with a paid sample t-test where I'll go with variable 1 as the runs and variable 2 as the first wicket partnership. The same logic again continues, right? There is nothing else to change. Now in this you see that the mean runs is 140, whereas the mean first wicket partnership is 26.9. I want to check out for the differences. Is there a significant difference between the total runs and the total first wicket partnership? What is coming out is the average runs is 140. The average difference in the runs is 140, whereas the average first wicket mean is only 26.9. And what we are seeing is the other thing that it is showing is the correlation, which is 0.264 between the first wicket partnership and runs. We will be looking at it later, that the higher is the number, very close to 1, we may conclude that the higher the first wicket partnership, the higher would be the run scored and vice versa. But here the number is not so big. So at this moment, I don't want to do any kind of a comment with respect to correlation. But what I'm simply saying is the paired sample t-test will also give us the correlation that is existing between the pairs of the data, and along with that it also gives us, okay, on an average the difference between the first wicket partnership and the run. This is a key important information for me. On an average the difference between the first wicket partner runs and the first wicket partnership is 113.13. okay, the average difference between the total runs and the first wicket partnership is 113.13, and it's also saying that the standard deviation between the same is around 40 units and the standard error being 1.56. So what it is also saying is the 95% confidence interval of the difference. So I am very much confident that the difference is somewhere between 110.05 to 116.21. The difference between the runs and the first wicket partnership lie, I am 95% confident that it will lie within this region itself. Very good information. So suppose the first wicket partnership is 50, I can very well say I am 95% confident that the team's score will be between 160 to 166. That is what is this information bringing out to me. This is the 95% confidence interval of the differences, and it is very significant. That is what is being brought out by your significant two-tailed test. So what can very well be concluded here is between two pairs of data, especially when I want to do the differences between the two pairs of data and I want to make some kind of conclusions based on the differences, I would be resorting to the paired sample t-test. So these are the three different ways where I can compare the means of the data and make some kind of conclusions regarding the calculated means based on the sample calculations. I hope you are clear on the three different business scenarios that needs to be used for comparing the means between the various data items, various populations using the sample. If you have any kind of further queries regarding the same, you can very well get in touch with me on the number that I have given below, or you can send in an email at vamsidhar@pacegurus.com and I can very well get back to you with the solutions to the queries. Thanks a lot for listening to this session. Thank you very much.